Good day, everybody. In this video, I'm going to explain a little bit more about the second project. So what I expect from you and what kind of task you need to do. So to start with, you just need to find where you can get the description of the project, and it's on the website. So you can either go through the modules and look at week 12. Then you're going to see description here. And also this link is for submission. So once you're ready, you can click on this link and submit your project. Another way to find the project description, it's through assessment. I don't forget what it's called. I think it's an assessment menu. So where you have all the assessments put together. So in this case, you will see there will be project description as well. So yeah, it will take you to the page with the description. And when you're ready to submit your project, you're going to submit your project using this link. So there is a change about the deadline. So I changed the deadline and extended it to the end of Sunday of week 13 so that you have a little bit of more time, because I know that some of you are doing hydrology and there will be a final exam for hydrology on the same day as I wanted you to submit the project for. That's why I extended it by 3 extra days. Hopefully it's going to help you. So once you go to the project description, so it's very similar to first project. Find what number, like what variation of the second project you are doing. It should be the same as project one, but still check the file. So there will be the file. So this is students S numbers, and this is the variation of project two. So see which one is yours. Again, same as project one, that's an individual assignment, which means that you need to provide your own report. Okay, let's go to the next slide. Okay, so that's this is a little bit different from the first project. So here I would like you to put all your questions together on the front page. So you will see, like, once you open the project description, there will be this table. So this task number. So 1, 2, 3. So there will be, I think, 6 together with the report. And I would like you to put your numbers here. So still you need to provide your workout, how you did everything, all the solutions, but also I would like you to put your answers here on the front page. It will help me mark your projects. Don't forget to put your name here and campus, Gold Coast or Nathan. This is the description. So I would like to build a canal. So there are two options to do that. So in the first option, we're gonna construct it immediately. So we will start with immediate excavation. So something like this. And for the second option, we are going to improve the properties of the soil before the construction, because this construction will take place on very soft material, soft foundation. And I would like to know, maybe you actually have to go with the second option. And this is what I would like you to tell me in the end of the project. You will see section 6 called report. So this is where you're going to put your thoughts and ideas and also discuss your findings. So there are 4 parts of the project. So the first is site investigation. So something similar to project number 1, but not as much as we did it before. Then we're going to analyze water flow before or during the excavation. So you guys gonna practice flow net drawings and analysis. Then there will be a part about consolidation using the embankment. And also, I would like you to estimate the slope stability of this embankment and look at potential failure planes and landslides. So everything that you've done in this course, and particularly what you did, I think, from week 5 and 6, will be here in this project. The good thing is also to look through those in-person tutorials. We have done lots of things that you can actually use for the second project. That will be very helpful. You're going to start with section 1. So section 1, it's not very long. It's actually probably the smallest section, but it's very important because it provides all these basic properties of different types of soil that you have. There is also a borehole log that will tell you the depth of each soil layer. So this information you will need at some point, especially when you calculate the stresses. So for some like topsoil, the unit weight is given. For sandstone, the unit weight is given. But there is no information about unit weight of the silty clay, which is the main material, main geological unit on the site. But you are given other values. So from using these values, you should be able to estimate the unit weight, something similar to what we did in the first project. You're also given data on the liquid limit and plastic limit test. I would like you to analyze the data. The same thing as we did in one of the laboratories on plasticity. And also I would like you to classify the soil using the plasticity chart. So remember there is that Casagrande plasticity chart that will determine if you have silt or clay. So that's the chart that you're going to use for this classification. Don't forget to do that. Also, you'll need to fill in all this table and answer all these questions where you have average, plastic limit, liquid limit, and plasticity index. The second section deals with flow nets, water pressure, and effective stresses. You're going to have set up something like this. This is sort of like a general sketch, and this is what you are going to use to draw flow nets on. So you're gonna, I think maybe probably the best thing is to print out this page and draw flow net on the paper, then scan it and attach it to your report. You can also use the software and draw on this file that you're provided. So you can draw on the file using software. It's up to you, but it should be clear. All the lines should be clear. Also, you should cover the whole area. So FlowNet will go for the whole area, not just part of it. You're also given the distances between different water levels. So, and you're also given the depth of point A. I think for this point A, you are supposed to calculate the effective stress. The other thicknesses, like probably this one and this one, so you're gonna get this from this borehole log here. So look at this borehole log. It tells you the elevation of each layer. So that will be very useful. So use this one and apply to this sketch. You're also given a scale. Here you're given scale as 20 meters. So this one will be equal to 20 meters. So as I explained in person tutorial, and I think it's one of the online tutorials on FlowNets, you're going to use this as a scale. For example, if you need to measure this distance, like this one, so in meters, so in this case, you use the scale and convert it into meters. For example, it will be maybe, I don't know, 2.5 meters, right? So use this as a scale. Section 3 will be about consolidation. Again, you are given the setup. You have alluvium clay, which is this one. So with all these thicknesses, elevations, just look at the borehole log, groundwater level as well. See how deep the groundwater level from the surface. So it's kind of schematically shown here, but you need to know the exact distance. And this distance comes from here. For this case, it's very similar to the laboratory number 5. What we did in the laboratory number 5, you are given this setup, and yeah, we know that we're going to build embankment, and it's going to made of the sand, and the properties of the sand is given it's given here. So use this information. I'm not going to tell you why you need to use this information. You should know by now, like why. So we did something similar, or at least we sort of discussed it in the laboratory number 5. So what you're given is that the height of this embankment is 3 meters, so that will be very useful information for you. So figure out why it's given to you as well. And what you need to do is to answer a few questions. I think there is tasks. I think section 3A, B, C. So basically you need to know the settlement of this alluvium clay and how long it's going to take to a certain level of consolidation. Again, we did something very similar in the fifth laboratory, or you could just watch problem videos. I think I have maybe a few videos that will explain how to solve these problems. Another thing that you need to be aware of, that you might have to do like one of those methods to estimate the time of the coefficient of consolidation. So just be careful which one you're going to use. It's written in that section number 3. So it's either going to be the log method or it's going to be square root method. Make sure that you use the right one. If you don't use the right one, you're not going to get any points. Please be very careful and read it carefully. So what method you need to use. You also need to draw everything, guys. Whatever I didn't mention for plastic liquid limit, you need to draw plot. For compression index, you need to draw plot. So for everything, you need to draw. We did very similar in one of the laboratories or in one of the tutorials. So you have to draw it, and you have to draw it using a proper scale. So don't forget to add labels to the axis, units, so everything should be there. Please make sure that it's all presented in the right way, because if your drawings are not of good quality, high quality, you're missing something, or you have no drawings at all, then you're going to lose many points. So just remember that one. There is also marking criteria. So in the marking criteria, it explains everything, what you need to draw, for what particular case, for what particular task you need to draw, how you need to draw. And also in this project description, you also see there's explanation what you need to do. Just read the task very carefully. If you need to provide the plot, then you just draw it and provide it, otherwise you're going to lose many points. There will be section about strength. So in this section, we're going to analyze 2 different types of soil. The first a few tasks, I think for A and for B, will be about sand. And this is the data that is given from a shear box test. So this is what we do in in-person tutorial 5. If you don't attend this in-person tutorial 5, then just watch the relevant videos. For this question, you see equation for A and for B, they're all connected. So you take properties for example, if you solve problem for B, the properties may be the strength, the shear strength of sand that you need to solve this problem. You guys should take it from this one, from question for A. So they're all connected. Just remember this, for A and for B, they're connected, and they're also connected to this set of data. So it's kind of like one set of data, and the questions about sand, whatever is missing in question for B, just find it in question for A. And I even wrote it down here. So this is slope stability in-person tutorial 5 or the relevant videos. That's what you need to watch. Also, just see if you need to consider seepage or no seepage. There are two different formulas, one for seepage, one for no seepage. Just be careful which one you use and provide the correct answer. For each of the tasks, you need to provide your working notes. So if you need extra pages, just add extra pages in your report. I would like to see how you achieved, how you obtained the answer. The second part of that section number 4, that will be about clay. For the clay, again, you are given a set of data, but this one is from 3 actual tests. So you have 3 tests. You will need to analyze it either using stress path. So this is what we cover in week 12, stress path. So see what we do. It if you cannot attend lecture and tutorial, then watch the recordings. For this one, you will need to actually draw more circle for each test. So this means that you have to draw 3 circles, and these circles should be to scale, to proper scale. And from this drawing, you're actually going to get cohesion and friction angle. So you will draw 3 circles, you will draw a failure envelope, and from your drawing, from this drawing, you are going to use, you're going to get the friction angle and cohesion. So once you get this friction angle and cohesion, you should be able to solve this problem. So again, these are all connected. So first, you will get friction angle and cohesion, and then you will use this friction angle and cohesion to estimate, I don't know what you need to use, portable pressure failure. So these, just remember this, these are all questions connected. So these questions, for example, this one we covered either in a lecture or tutorial, online tutorial. So check the recordings or the notes. Section number 5, it's give you opportunity to practice more circles, to like drawing more circles and estimating the normal stress and shear stress on any inclined plane. So that's not very difficult, not much to explain. So for example, for this one, 5B, you just need to calculate the normal stress and shear stress on plane AP. And that's what you guys did in quiz number 2. So see how you did the question in quiz number 2, and just probably like, if you did really well, then just like do the same thing. For this question 5A, I would like you to draw more circle. I'd like you to draw with the proper and accurate scale. So don't just give me a sketch. If you're going to give me a sketch, most likely you're not going to get any marks for that. So it should be like a proper drawing. And the scale, the scale that you're going to use to estimate the principal stresses. So what I would like you to do for these 5A tasks, you give me your best drawing of the Mohr circle with the best axes and like coordinates and stuff. And from your drawing, you determine the value of the principal stresses. You don't need to calculate them using the formulas. I want you to get them from the drawings. I want you to practice drawing. So most likely you need to use the drawing compass and stuff like that, but this is what you need to do to get the full mark for this question. And this one is section 6, that's a report. I think you did something like practice a little bit for the first project when you gave me your thoughts and discussed your findings about the geology of the site. So this will be a little bit more advanced compared to project number 1. So I will expect you to write about 1 page, and you not only summarize your findings, so that's what you need to do, but you also need to give a description and do some analysis. So to make it easy for you to know what to write about, so that you'll be very specific. Do not give me just very general information that may not be even relevant to this particular site. So I put some of these notes and questions for you, so it will kind of guide your discussion, so guide your report. So this is something that you need to write about, or you need to explain, or you need to discuss it more in details. Also would like you to provide some literature references, especially when you talk about the range of the properties of that particular soil can have. So just read this one. Another thing, you can also read the marking rubrics. So I think it's also given there. This one is also given in the description of the project. So just to help you to write this part of the report project. Okay, I think that's about it. I'm going to explain it during the lecture in week 12. If you guys don't attend that lecture, just watch the recordings. If you have any questions, please ask me during the lecture. I'll be happy to answer. So, yeah, good luck with the project, and have a nice day. Bye.